These videos that I've been making here have been teaching how all these various things that happen out there are related to the ocean of matter that we're all in. Space and time and matter are no different. Space is not actually empty. It's filled with matter. Otherwise, space wouldn't be anything at all. But space is something. And that's why we can measure distance. When we measure distance, what we're really doing is we're measuring the stuff between this point and this point. And so we measure all the stuff between this point and this point in a line. If we're measuring in a line here, then we're seeing the distance between here and here. The same thing can be said of time. When you have time, you also measure it in a line. So just like space is measured in a line, so time is also measured in a line. And this is because of linear matter displacement. So here we have a bin of stuff, and if we wanted to move forward in this stuff, we would have to push forward like this. You see how my finger goes through this stuff? In order to go through this stuff, my finger has to push its way through the stuff. The more stuff that's blocking my finger, the more time it takes for my finger to move through the stuff. Unless, of course, I have more push or put more push behind my finger. If I put more push behind my finger, then it goes through the stuff faster. Why does any stuff cause a longer time to occur? And the answer is very simple. It's because stuff is time. Time is stuff. Now, the stuff is not linear time. It's not time in a line. Rather, stuff is fully existing. It's like a piece of three-dimensional time. A chunk of the present. So, when we displace a piece of matter, if we have a piece of matter and we're displacing it in a line, then we get linear time out. Why? Because this is a piece of time. In fact, anything is a piece of time, because matter is both space and time. Now, whatever you can say about space relating to space, you can also say about time relating to time. When you measure across something, whatever you measure, whatever you're using to measure with, you're always measuring, like, for example, this tape measure, you're always measuring across that thing with something else. So here we have matter or stuff or whatever you want to call it, and it's an amount of stuff that we measure across other stuff with. So the point is that it's always a comparative tool. For example, we could use this much stuff to measure across this piece of stuff. So when we measure across it, we can say, oh yes, it is approximately 3 inches. Why did that work to measure space with stuff? Because space is stuff. Space is stuff, and so when you use a linear measurement of space, you can measure other space. Space is not empty, it's full. The same thing can be said of time. Time is full. It's matter. It's real stuff. That's why when you push on this stuff in a linear fashion and push it through other stuff, it takes time. We just displaced this matter, actually we displaced this matter in a line with this matter. Let's do that again. Now you see how that takes time? We can make a clock out of this. We can, as long as we apply the same amount of push on the one side, and it's that push is being hindered with the stuff on the other side, what we're really measuring is how long it takes to displace the stuff by applying push on the other side of this stuff. That's the basis of all clocks. We measure time in many ways, but in reality we're only measuring time in one way: linear matter displacement. And what we're really measuring when we measure linear matter using linear matter displacement, which is the cornerstone of all clocks, it's the way all clocks work, is we're measuring matter. Now here in this hourglass, we're measuring as the sand. We're measuring the sand displacing the ocean of matter that we're all in. Here in this analog clock, this little wristwatch, we can use a pendulum to displace the displace the ocean of matter that we're all in. And this could be pendulum-based linear matter displacement. In this wristwatch, we use linear matter displacement in the form of electrons, which can go back and forth inside a small timing crystal. How that works inside the timing crystal is really kind of interesting. What happens is the electrons flow into the one side and the crystal extends out like that, and then it deflects and the electrons race around to the other side through the circuit, and it goes back like that. The crystal they use for that is a piezo crystal. So when we measure matter across matter, we're measuring space, and when we measure the matter displacing other matter in this ocean of matter that we're all in linear matter displacement, we're getting a measure of the matter that's being displaced. We're getting a measure of the push behind the matter and the matter that's being displaced as well. In fact, to accelerate matter, you would need to have stuff. You need to have more stuff behind it and less stuff in front of it. And if this had the push of more stuff behind and less stuff in front, it will accelerate. To decelerate it, you have to have the opposite of that. You have to have more and more stuff that it crashes into and less push behind it. So that's acceleration and deceleration, explained very simply. And it is a very simple happening. And it is responsible for all accelerating forces and decelerating forces. It's just the push of the matter. What's more in front of this matter versus what's more behind this matter. There's more and more behind it and less in front of it, it will accelerate. Why? because again, matter is time. So there would be less time in front of it and more time behind it, pushing it along. And that's acceleration. For deceleration, there would be more time in front of it and less time behind it, and therefore it took more and more and more time, and it would slow down. And that's the fundamental basis of acceleration and deceleration according to any force. Now, it used to be thought that gravity was caused by a warping of space and time. And that's kind of true. But what you have to remember is that matter is that space-time web. So if you have if you're talking about a space-time web, then you've really got a kind of like a matrix of matter that is responsible for gravity. So, and if you remember in the previous videos what gravity is, that it's just larger pieces of matter fitting well with larger pieces of matter, and thus, because it's drawn into those holes, its large matter tends to come together. That reaches out into space like great chains, because nothing acts at a distance, only about what's right there. So indeed it is true to say that space and time, which are matter, are responsible for gravity. But when you understand that space and time and matter are one thing, not three different things, then it becomes very, very simple to understand not just the force of gravity, but every single perceived force. Every single perceived force can be fully explained simply by realizing that space, time, and matter are one. So matter is this space-time web. Understanding space and time is to understand motion. Understanding motion is the key to understanding every perceived force as an inaction and simply a state of being of the matter. One thing is responsible for all of it, and so is the finalization of the grand unified theory. Both acceleration and deceleration can be explained simply by understanding what's in front of the object and what's accelerating the object or not accelerating the object when it's being decelerated. So if you understand where that matter is and what's around it, you'll know what's going to happen to that matter, to that stuff. And that's it. That's all that time really is. Time is the matter. Time is not the linear displacement of the matter, just as measuring across the matter. If you measure across the matter, that's not the matter either. So you can't measure across an object and say, I know the measure of that object. Well, you know a linear measurement of that object. Just like if you had a chunk of matter and you could measure across it, well, not measure across, but if you could displace it linearly, you would have a linear measurement of that object. But and that linear object would be, time displacement, and you can get a reliable measure of the matter by measuring the linear time of that object according to what's around it. But that's, a linear measurement of the time is not time either. Time is, and space is, the matter. It's the present time. It's the present. It's everything that exists, physically speaking. So you can't go forward in time and you can't go back in time, because there is no forward in time, no back in time. There's only the forever present. But how can that be? How can there be no back in time or forward in time? Because it seems like I remembered what happened yesterday, and yesterday seemed like a time that existed. Well, the time existed, the linear displacement happened, but what I did was I recorded the linear displacements in my brain. And so the memories of what happened were displacements that occurred in my mind to log the linear displacements that happened. But that's linear time. And now linear time doesn't exist separate from the matter that creates those linear displacements. So the forever present, the time that the things happened with, the pieces, they exist everywhere, and everything that was here yesterday is here today. And those pieces, they still exist, but now they're in different places. And because they're in different places, and because the pieces in my mind are in different places, that I've logged the events that happened out there by changing what's in here. And so by changing what's in here according to model what was out there, I've logged what had happened out there. But what had happened out there was nothing. Nothing happened. And that's another thing about the matter. Because you see, the only reason why a chunk of matter moves, like this piece of matter would move, was if there was less time, less pieces of stuff, less, if we're calling matter time, which we are here, there's less stuff in front of it and more stuff behind it, then it's displacing a lack of stuff. So what it's doing is, because it's displacing some stuff here, that takes time. But if there was nothing in front of it and stuff behind it, it would take absolutely no time to be there. And that's a thing of the matter, because you see, the matter is something that's real. And a hole in space, that is a lack of stuff, if you could have something that wasn't there at all, there was like a hole, if space was actually empty here, and space is never empty because the matter would expand into it instantly, which is exactly what would happen. The stuff would expand in instantly, boom, it would be instantly there. It would take absolutely no time to take over an area with no time. And of course that's the idea of acceleration, is that if you have less time here, it would accelerate into it. But if you have no time here, it takes no time to take over where there's no time, because this is a piece of a fully existing time. In other words, this is something that exists. So for this to take over something that does not exist takes absolutely no time. Why? Because it's not doing anything. It's simply being. And that's the point, the purpose of every physical interaction, is that it's just a state of being of the matter. The matter doesn't actually do anything. In fact, nothing ever moves relative to itself. It only moves relative to everything else. So, if you look at the individual happening with this thing, when it takes over, when it accelerates, or when it decelerates, or when it tries to move at all in any direction, it's not moving relative to itself, and therefore nothing is happening. So matter's state of being is what's crucial to understand, drives all physical happenings. And so it's all boiled down to one interaction. All physical happenings are boiled down to one physical interaction, and that's matter, a piece of matter just existing, just being there to be pushed around by other matter. And so this simpleness can't get any simpler, because we've boiled down all of science to just one thing, one interaction. I guess that's what people would call the grand unified theory of everything, is, physically speaking, there's really only one interaction, and that's just matter just being there to be pushed and pulled around. That is a piece of physical existence, which is what matter is, which is what stuff is. It's just there. And it's just there as pieces of the present time and pieces of the present space. But again, why is every interaction, why is every action considered to be an inaction? And that's because whenever matter moves, whenever it's pushed by one thing into something else that's less matter, what's happening is you have something that exists through its existing, taking over what does not exist. And so it's literally doing that nothing. It's doing that nothing there that doesn't exist. So by saying that this takes over a lack of something, something takes over a lack of something, it's when it takes over that lack, it is literally and figuratively doing nothing. It's doing that nothing that's right beside it. And so if it is doing the nothing, then what it really is doing is just being itself. It's just being there itself. So it boils it all down into this simply existing, the basis of all science. So space, time, and matter are all one thing, and they are pieces of physical existence. And what exists has been and will always be, physically speaking. It's almost like God made a picture of the matter be like a parable of himself when he made the matter, because in the Bible it says that the first name that God gives to people to call him is I am. And all the matter is that it just is. It's just there, it just exists. And it's infinite, and it just keeps going and going and going. There's no end to the matter, and there's no end to God. We know that there's no end to the matter because if there was an end or an edge to the matter universe, then it would instantly blow up and explode outward, and it wouldn't take any time for it to do it, because there would be no time out there on the perimeter to prevent it from instantly expanding into the emptiness. And it's amazing that all of science is built on something so simple that it's nearly beyond all understanding to realize that all science is built on just one thing, and that's just pieces of physical existence. And just through their existing, they do everything that they do. And every perceived force and every perceived property of matter is actually a result of matter just being there, just physically existing.